Hello and welcome to today's lesson on the basic structure of atoms. In this lesson, we will explore the structure of atoms, focusing on protons, neutrons, and electrons. From this, we can understand the concept of atomic neutrality and how it relates to the number of protons and electrons. Previously, we discussed the properties of matter. Now let's delve into the building blocks of all matter, atoms. Atoms are the fundamental building blocks of matter, forming the basis of everything around us. You can think of atoms as the tiny bricks that make up all substances, from the air we breathe to the screen you're reading this on. Imagine breaking down a piece of anything, say a piece of metal or a droplet of water, into smaller and smaller pieces. Eventually, you would reach a point where the piece is so small it can't be divided any further without losing the properties of that substance. That smallest piece is the atom. As you'd expect, atoms are incredibly small, with a typical radius of about 1 × 10 to the power of -10 meters. A single human hair is about 1 million times thicker than an atom. Despite their minuscule size, atoms have a complex internal structure consisting of 3 main types of particles: protons, neutrons, and electrons. At the heart of an atom is the nucleus, a tiny, dense core that carries most of the atom's mass. The nucleus contains 2 types of particles, protons and neutrons. Protons are positively charged particles with a relative mass of 1 unit and a charge of +1. The number of protons in an atom defines what element it is. For example, an atom with 1 proton is hydrogen, while an atom with 6 protons is carbon. Neutrons are neutral particles, meaning they have no charge, which also have a relative mass of 1 unit. Neutrons help to add mass to the atom and keep the protons in the nucleus together. Surrounding the nucleus is a cloud of negatively charged particles called electrons. Electrons have a -1 charge and are much smaller than protons and neutrons. They have a relative mass of only about 1/2000 units. Electrons in an atom are arranged in energy levels or shells, which are at different distances from the nucleus. The first shell is closest to the nucleus and can hold up to 2 electrons. Subsequent shells can hold more electrons and have higher energy. Think of it like climbing up a ladder. The higher up the ladder, the more gravitational potential energy you have. Similarly, the farther the electrons are from the nucleus, the more energy they have. The arrangement of electrons determines how atoms interact and bond with each other. Even though the electrons occupy the majority of the space in an atom, they contribute almost nothing to the atom's mass. Nearly all the mass of an atom is concentrated in its nucleus due to the protons and neutrons. The radius of the nucleus is incredibly small, less than 1/10,000th of the atom's total radius. This means that almost all the mass of the atom is packed into a very tiny space. If an atom were the size of a football stadium, its nucleus would be the size of a small marble at the center of the field. The rest of the atom would be mostly empty space, with the electrons whizzing around the stadium like tiny gnats. The following table summarizes the properties of protons, neutrons, and electrons. Despite containing charged particles, protons and electrons, atoms are electrically neutral. This is because the number of protons, positive charge, is equal to the number of electrons, negative charge. Therefore, the total positive and negative charges balance each other out, resulting in a net charge of 0. For example, oxygen has 8 protons, 8 neutrons, and 8 electrons. Each proton has a +1 charge, giving a total charge of 8 multiplied by +1 charge equals a +8 charge. Each neutron has a 0 charge, giving a total charge of 8 multiplied by 0, which equals 0. Each electron, however, has a -1 charge, giving a total charge of 8 multiplied by a -1 charge, which equals -8. Hence, this gives a neutral charge for the atom as +8 + 0 + -8 equals 0. As shown, the atom is electrically neutral. If atoms lose or gain electrons, they gain an overall charge, and we say they become ionized. We will examine this more in later lessons. In today's lesson, we explored the basic structure of atoms. learning that they are composed of protons, neutrons, and electrons. We discussed how atoms are incredibly small, with most of their mass concentrated in the nucleus. We also introduced the concept of energy levels, where electrons are arranged at different distances from the nucleus. By understanding the relative charges and masses of these subatomic particles, we learned why atoms are electrically neutral. Understanding the structure of atoms is crucial, as it forms the foundation for exploring more complex topics in chemistry and physics. Understanding these concepts is crucial, as it connects to many areas of science and technology, from everyday lighting to advanced spectroscopy.